Good morning. Welcome to the next EN31T lecture. Today our topic is regular expressions. Today and next week actually. Today I will teach you most of the basics of regular expressions, and next week some more advanced techniques that you can use. So as you might already know, regular expressions is extremely important for your next assignment. So you will be extensively using regular expressions. And hopefully you will have a much better idea what this is by the end of today. So first of all, we should discuss what regular expressions actually are. It is a language to describe patterns of text. And the reason why this language is so popular is because many tasks involve searching and replacing patterns in huge text files. So imagine you're data scientists and you get maybe Excel files from a collaborator, and your task is to kind of import this from a database. Right? There's a lot of cleaning steps required that where you have to select certain aspects of the input files and then copy them into the database. And so it turns out to program these finding certain text patterns in a text file is really cumbersome in classical Python or in classical computer languages. And regular expressions are much, much more powerful to do these tasks. And yes, so the lecture today will be a little bit different to what I've given before. And the reason is because originally they used to be given by Jonathan Feinberg, who used to be a guest lecturer but couldn't come today. So I give his lecture today. And so we will do live coding. So I will do, we will kind of interactively develop some problems and let's see how it goes. So first of all, so essentially the way this is built up is that on my left I have some slides, and then on the right I have a terminal where I can run the code. And there's some kind of text, but there will also be some programming on the left-hand side. So, but the first occurrence that you might, or the really useful way of using regular expressions is actually in your editor. So many more advanced editors have a regular expression engine built in, and you can use that engine to search and replace text. And so, of course, you know, simple search and replace is available from any text editor, but if you use a good editor, for instance, I use Vim, but also if you can use your favorite editor. So, for instance, if you use Sublime Editor, and you go here in find and then replace, right? That's the common search. And then down here you have some options, and you can see here on the very left, you can switch on this .star button. If you switch this on, then you have the regular expression engine switched on, and you can use the regular expression language to do search and replace. So, many programming editors have this available. But I just want to demonstrate you as a motivational example why regular expression is so much more powerful than the simple search and replace. So this is an example. This is a code example here where I do some stencil calculations. Right? So this is my daily bread and butter that I have to do some calculations like this, and it involves a lot of indices. And so I sit down and kind of think about what these indices should look like, and then I code them up here. Now, stupidly, I've done a mistake in this code. Namely, I mixed up the J and I indices throughout this. I mean, this is just 20 lines, but it could well be also 100 lines of code. So now, what I would like to do is I want to essentially replace all the J's and the I's in these brackets here. And so what I can do now is I can start the regular expression engine in my Vim editor. And the way I do that is, so this is going to be a little bit of cryptic, but at the end of the lecture you will understand what I'm doing. So %s starts the replacement of text. Then I have a \v to start the regular expression engine. And now I describe the text that I want to have replaced. So I want to have the open brackets. This is the text that I'm looking for. Then I want to have some characters that I want to have replaced by, up to a comma. Then I want to have a space, and you can see while I'm typing, it marks all the text that it's currently matching to. Okay, so then I want to have some more text that I would like to replace, and then finally there's going to be a closing bracket. And so now I can, so this now describes the text that I would like to match, and now comes the part where I describe what I want to have it replaced it with. So now all this original text is gone, and what I type now is what it's going to be replaced with. So now I want to have the bracket again, and this time I want to have the indices swapped. So everything that was now on the second and this after the comma is now in front of the comma. And everything that was in the front of the comma is now in the second and after the comma. Right? So this is something that would not be trivial to do with the standard editor, but it is possible to do with a regular expression. So just to show you this again, I can go back and forward. So this was, you see the step it had swapped it. So just one command that looked maybe a bit complicated, but you learn how it works soon. Okay, so let's start very simple. So let's assume we have a string in Python. And so, of course, regular expressions is also available in Python. So everything that I've shown you also works in Python. And so let's say we have a simple string up here with a lot of spam words. And you can already see there's some variation of, no, actually here it's only spam words. Sometimes it's, yeah. And so let's say we want to replace all the spam with ham. So what do we do? So we can start our regular expression engine, and for that we need to import the regular expression module, which is called RE. And then, well, of course, the first thing that we could do is we could try to avoid regular expression totally. We could just use the standard Python features. And so it turns out every string in Python has a .replace function. And then what you can pass in is the word that you want to have replaced, and then the text that you want to have it replaced it with. So this is a perfectly fine start, and that for that we also don't need the regular expression engine. And if we run this, I can here be running the substitution.py, and you can see in the output text all the spams have now been replaced by hams. So this works just fine. So now we can do exactly the same, but using regular expressions. And the way we do that is that instead I use the re.sub function. So sub stands for substitute. So I do a regular expression substitution. And then I provide again the word that I want to substitute, the word that I want to have it substituted with, and then as the last argument I provide the string that where I want to apply the substitution to. So now this, if I run this script again, as you can see, I get exactly the same output again. All the spams have been replaced with hams. But now we can do some more fancy things. So now let's say we have some, let's add some parts here. Let's add scam here. And let's say we also want to replace words where we don't care about the second character in spam. So we also want to replace scam. So then what you can do is we can tell the regular expression that instead of specifying the second character, we simply add a dot. And a dot in the regular expression language stands for any character. So we can have a list here. So dot is any character in the regular expression language. So now this first item here matches any text that starts with S, then followed by any character, and then followed by an A and M. And so this should now match both scam and spam, for instance, but of course also all variations. So let's try again, and indeed the ham is now, so the scam, which was the last word, is now also replaced by ham. Okay, does it make sense? Kind of? Okay, let's make things a little more challenging. So now I've made the text a little bit more complicated, and you can see now we have all kind of variations of spam down here. So we have some numbers and some special characters in here, and so on. And so now often it would be nice to be more specific about which spams you want to have replaced. So what we want to do is we want to specify exactly which character classes we want to target. Yeah, that's a question?
One of the spams haven't been replaced.
Yes, so good point. That's because regular expression is case sensitive. Okay, so if I used a capital here, then you see this one after Viking is replaced, but of course all the other ones aren't replaced. Yes, so the obvious question is it possible to replace both small and capital letters? And it is possible. And you will know how to do this soon. But exactly, so I mean, your question is already kind of getting in this direction. Often we want to be more specific which characters we want to replace, be it capitalized or non-capitalized, or even wider, do we want to replace a word character or a digit character, for instance? And so we have special character classes for this. So remember dot. So we make a list here. So dot stands for any character. Then we have \w, and \w stands for any word character. So I explain to you what I mean by that. So a word character can be any small letter from A to Z. It can be any capital letter from A to Z, or it can be any number from 0 to 9. So if we place a \w in here, down here, instead of the dot, then we will target words that have in the second entry a word character, and all the other ones we will not target. So now I need to have a little break here, because this unfortunately won't work. So we can just test it, but you'll see that we get an error. We actually don't, but that's just because we are lucky. So the problem is that in Python, if you have strings, the \/ indicates that there's a special character starting. And so typically we need to escape these characters. So for instance, if I want to print a, just to give you a simple example, if you want to have a string that contains the letters \n, and you just write it out like this, and you print it, oops, print \n, then instead of seeing a \n, you actually see a new line, because \n is a special character that represents a new line. And \n you might know, but there are some more fancy special characters, for instance, the \b. Does anyone know what the \b does? It deletes a character. So it's a character that deletes the, in fact, it moves the cursor one to the left. So if you, for instance, if you have A and then \b, B, then what's going to happen is that you print out A, then you move the cursor back, and then you print out B. So the result is simply B. So the point here is that in regular expression, we typically, when we write a \, we typically we don't want to have these special characters, but we really do want to have the \ passed to the regular expression engine. And for that reason, so there's two options, right? One option is that you double escape the \. So you can write a \n, and then you get what you want. Or in our case, right, we wanted the w, \w. But this becomes very cumbersome because there will be a lot of \. And for that reason, we can add an R in front of the string definition. And that indicates that we're talking about a raw string. R stands for raw, simply meaning that we don't want, that we want to keep the string, we want to read that string literally. So \ remains a \. So that was the deviation. So here, in order for this to work robustly, I use a R in front of the string definition. And that's essentially, you can keep this as a, in almost all regular expressions, the first, the regular expression where you describe the pattern, you typically always want to have an R, indicating that you're talking about a raw string. So let's try it. So this now should replace any spams where the second character is a word character. Now there is no so many, actually we should move it to the second one. So let's do that. Okay, let's try this again. So do we have a, let's see.
Isn't it the wrong file?
Oh yeah, good point. There's okay, so we, am I? Yeah, exactly. So for instance, here the SP7M has been replaced by a ham because 7 is a word character, right? And the SP%M has not been replaced because percentage is not a word character. Right? So now we can be more specific about what we want to replace and what not. So there's also a specifier for non-word characters, and that's the capital W. So capital U describes non-word characters, and so that's essentially everything that is not a little w, counts as a non-word character. So if we try that again, now we should see exactly the opposite to before. Right? So SP7M is still there, but then the SP$ham has been replaced by by ham. Okay, and so the last one that we would like to, the last very common character specification is a digit, and that's a \d. So it's a digit character. So that's simply 0 to 9, and then you also have the capitalized version. That's a non-digit character. So that would be not 0 to 9. So all these you can use in your regular expressions. Okay, any questions so far? Yeah?
Is it possible to replace both the letters and the special signs, like in getting all the spans at one?
Yeah, so in that case, you would use the dot character, right? So dot matches any character.
Oh, yeah, of course.
Yeah. But we will learn techniques on how, if you only want to have little s and big S, for instance, right? So if you want to have a subselection of the word characters, that you can also do. But I'll show that to you a little bit later. Okay, so as I mentioned, there's some special characters that regular expression uses. So these characters that I've marked up here, these all have a special meaning in the regular expression language, which means that if you want to search for if you're looking for a string that contains a dollar, for instance, then in your regular expression, you need to write $, okay? Because otherwise, the regular expression engine interprets the dollar as having a special meaning. So be aware of that. So again, if your pattern matching includes any of these characters here that you're looking for in the string, then you need to escape them with a \. Okay? And so of course, in order to make this work with the Python classes, you need to add the R for the raw string, or you need to double escape it if you don't want to do that. Okay, so now let's look at a real case, one first real case example. And that example is the task of validating a MAC address. Okay, so MAC addresses are unique identifiers of devices in a network, and they have this form. They consist of some numbers or characters, of always 2, separated by a colon, and then you have 1, 2, 3, 4, 5, 6 of them. Okay, and so this is a valid MAC address. This one is not valid because it only has 5 of these double character classes. And this one is actually an invalid one because it contains invalid characters. So a MAC address may only contain characters from A to F. So P here is invalid, and the little q is invalid. Okay, and our task now is to write a regular expression that checks if the MAC address that is being passed in is a valid one or not. Okay. So, and the way we do this is through test-driven development. So you've learned this already in the first assignment. And last time you used PyTest. Today I show you another engine, an alternative to PyTest that you can use. It's called doctest. And the way that works is that it's a Python module that actually checks the documentation, and it interprets code in the documentation as examples and runs them and checks that the output is the one that is shown in the documentation. So let me demo this to you. So what we need to do is we need to import, okay, so down here I import doctest. This is the module for testing the documentation. And then I simply run the test mod function. And then typically for this, because I might want to use this validate Mac function here as a module, so I add the if name equals name trick here, so that this testing code is only executed if I run this as a script. Okay, so now what happens? So this, of course, doesn't work yet. So I just add a dummy statement down here that the function returns nothing for now. So now we can run this script. Let's see what happens. And nothing happens. This should be main. Okay, so now what happens is that doctest runs this function up here is valid Mac, and it interprets these lines here as Python code, as a test that should supposed to be run. So it creates this list up here, and then it runs this print is valid Mac with the list as an input. And then it checks that the output of the function is equal to whatever I've written down here as part of the doc string, right? And so you can see on the right-hand side that at the moment this test fails because expected was true, false, false, right? This is the because the first MAC address was a valid one, and then the other two were false. That's why I added that. But it got none, okay? Because I haven't returned anything in that function. So at the moment, of course, our test fails. So our task now is to make this, to implement the regular expression. So how can we match these regular expressions? Well, the very first idea is to simply describe the pattern that we are looking at. So we know every MAC address starts with a word character, followed by another word character, then followed by a colon, and then we have another word character. This is the second pattern, then another one. Now we have 3, 4, 5, 6. Okay? So we have always 2 word characters, then a colon, and then 6 times in total. Okay? So it's quite lengthy, but that's our best guess for now. And so now we need to apply this regular expression to the string that we get in, to the addresses that we get in. And so, so far I've only shown you the re.sub, which does a substitution. There's also another function that is, it's essentially substitution and finding patterns in text that are the most important one. There's re.findAll that essentially works very similar to the substitution, but instead it tries to find the text, the pattern in the text, and returns the text if it found it. And if it couldn't find it, then it simply returns a simple an empty list. Maybe let me just show this to you in the previous example. So here, let's say I'm interested in finding all the words that start with SP, and then have a non-character word and end with M. Right? Then I can use this findAll method. And so if I run this, Python 03, so see, now I get a list with all the occurrences. of that pattern class. So sp question mark m, sp and m, sp percentage m, and so on. Okay, and so of course if you describe a word that never occurs, let's see if I have a pattern here that never occurs, then I simply get an empty list. Okay, so exactly that we can now use here. So we're trying to find words that match that regular expression. And so we loop over all the address in the addresses that we get passed in. Okay, and so then we can, let's just see what we get here. This will not quite work yet, but we can at least look at the output. So now what we can see is we get a list in the first case. We matched the regular expression, which is good, because it was a valid one. The second one was too short, so here we didn't get a match. And the second one got also a match, so here we need to improve our regular expression, but yeah, these are all word characters, so we expected a match here in this case. So this works now. We just need to convert this into true or false. So what we can do is we can simply write matches equals, I do another list comprehension. I check if that matches an empty list. Then I return is not the empty list. Right? I want the, if it's a valid MAC address, then the list will be not empty. And if it's invalid, then it's going to be an empty list. So I just simply convert this into a list of true or false statement, depending if we found it or not. Okay, and so now we're getting closer. We're expecting true, false, false, but we're getting true, false, true. Okay, and the last one is incorrect still because we haven't refined our regular expression enough yet. Does it make sense so far? Yeah? Okay, so what was, now we need to be more specific with which characters we want to match in the MAC address. As I mentioned, the only valid characters are A to F, and so anything after the F in the alphabet should be invalid. And so regular expression allows us to specify character, be more specific about which characters we want to match. And so before we do that, I will first rewrite this a little bit so that that I don't need to duplicate so much code. So I will have one variable that describes the character that I want to match. In this case, let's just keep it the \w. And then here, I replace this code with regx equals. And I use the join function to have the code more compact. So I want the character always 2 times. And then I want to have this joined with the colon in total 6 times. So these 2 lines should now return exactly the same result, except that I should probably use the raw here. Okay, let's just check that. So if I do a printed regx here and do the same here, we probably get the same. Yeah, looks good. So I've just added a 1-line statement that generates me this regular expression. And so the reason why I do that is because now I can play around with this \w character. So at the moment, we are matching any word character, but we want to be more specific. And the way you can describe a set of characters that you want to match is with square brackets. And in the square brackets, you can write which characters you want to match. So in our case, we want to match 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay? That's it. And so now, let's see what happens. Nothing happens. It's all false. Okay. That was unexpected. It's case sensitive, yes. So a good point. F. Let's also add the capital characters. Good, thanks. So now if I run it, nothing happens. And if nothing happens, that means that the tests pass. The regular expressions work exactly as they're supposed to. Okay? So this, again, the curly brackets, this is how you can specify a specific set of characters that you want to match. And of course, this becomes a bit cumbersome if you have to write out ranges like this. So in regular expression, you can actually write also ranges with a minus notation. So if you want to match any characters from 0 to 9, any numbers from 0 to 9, you can simply write 0 minus 9. And the same thing also works with the alphabet. So you can match A to F, and you can also match capital A to F. And so this should still work. And I've actually shown you this notation before already. So if we go back to here when I talked about the word characters, on the right-hand side, I've written out the equivalent notation in regular expression. So instead of writing word character, you could have also written bracket A to Z, capital A to Z, and 0 to 9. So that's equivalent. And you can also see if you want to negate that, all you need to do is you add a hat in front of it. Right? If you have a set of characters, but you do not want to match that set, you simply add a hat. Let's see. Okay, so now let's make things more complicated. I'll add another MAC address here, and I make it too long. So I add 43 here, and so this is of course also, it's too long. And we should now also extend the expected output. We expect a false here. Okay, let's see what happens now. So I should add a valid one. So I take a MAC address that was valid, and then I make it invalid by making it too long. Okay, so our regular expression returns true in this case, and that's not so surprising because we do find 6 double characters separated by a colon just fine in this string, right? So the regular expression engine is happy, and it returns true in this case. But we are not happy because we want to be more specific. We want to have these double characters separated by a colon, but then it should stop after that. After 6 double characters, the string should stop. Okay? So we need to have a new tool in our language, and that tool is called anchors. Okay? So anchors are a description of characters that are not visible, so to speak. So one anchor, for instance, is the head which is represents the beginning of a line. So, of course, the beginning of the line is not really a real character, but you can still use it in the regular expression engine. The same thing is with the dollar. So the dollar represents the end of the line. And then you have the backslash B, the boundary of a word, and the backslash capital B, not a boundary of a word. And so here you need to be, again, I just want to highlight this again. So if you use the normal backslash B in a non-raw string, it has the interpretation of moving the cursor to the left, right? But in the regular expression interpretation, this means boundary of a word, right? So you really need to keep, there's multiple levels here. There's the Python string interpretation, and then there's the regular expression interpretation of strings. And that's why we always use these raw strings, because we don't care about the Python string interpretation. But now we can go back and fix our example. So we want to extend our regular expression. We want to say that the regular expression is the beginning of the string followed by what we just had, the regular expression, followed by the end of the string. Okay. So now we are matching exactly the same pattern as we had before, but we're requesting that the string starts and ends, that comes nothing before and nothing after. Okay. So let's try this again. And now it works. Okay. Any questions so far? Yeah? The question is, would a word boundary work? And that's a, well, let's try it. So that was a backslash B, and I need to add a row here. And I guess we can use it in both cases. That did not work. But so let's see what happens if we have hello world. That still doesn't work. So let's see what we get. Oh yeah, it this. Oh, this is valid, of course. I'm sorry. I want to have this invalid. Oh yeah. To be honest, I'm not entirely sure, but I might suspect that the colon is a word separator, and therefore we need to use the. So essentially, you want to, you need to be a bit more selective here. Yeah. Okay, but shall we have a break and start again in 15 minutes? Yes.
Röra här,